Hi everyone. So good afternoon all. Good afternoon. Anand, good afternoon here. Good afternoon. Okay. So first of all, let me know whether audio and video everything clear here. Is audio and video everything clear? Yes. Yes. So if audio and video everything clear, then we can start the session here. We can start the session. So I am just waiting for your reply here. Is audio and video everything clear? Yes. Okay. Okay. So I hope it is clear. So next. So in the previous session we have started electrostatics. Yes or no? So we have started electrostatics. So what I have told here, so I have given a statement here. I have given a statement that is all this electromagnetism is just because of an intrinsic property that is possessed by the fundamental particles of an atom. Okay, so I have explained what do you mean by intrinsic property and what are the fundamental particles of an atom. So the intrinsic property of fundamental particles of an atom is nothing but what? Is nothing but charge. Yes or no? So I said that this charge is responsible for what here? Responsible for all this electromagnetism. So I have given the example also. Yes or no? So if you consider a stationary charge, it is going to set up an static electric field. Yes or no? A stationary charge is going to set up a static electric field. So if the charge moves with uniform velocity, it is going to produce a steady current, and this steady current is going to produce a steady magnetic field, or you can say static magnetic field. Yes or no? Now if the same charge oscillates with respect to time, so that means its velocity is changing with respect to time, then it is going to produce a time varying current. It is going to produce a time varying current, and this time varying current is going to produce what here? A time varying magnetic field. We are going to study that this time varying magnetic field in turn is going to produce time varying electric field, and this time varying electric field in turn is going to produce time varying magnetic field. One is going to produce the other, and they are going to travel through space, which we call them as electromagnetic waves. Yes or no? Okay, so a stationary charge is producing electrostatic field, and a steady current is producing a static magnetic field, and a oscillating charge is producing electromagnetic waves. Okay, so for electric field, magnetic field and electromagnetic waves, what is the cause here? Cause is nothing but charge. Yes or no? Okay, so that's what I have explained in the previous session here. Next next we have seen that whenever you consider any material, let us say some neutral material here. If you consider any neutral material, so even though that neutral material consists of huge number of positive charge carriers and huge number of negative charge carriers, still we cannot see any effect of charge, because the number of positive charge carriers are in balance with what here? Number of negative charge carriers, and hence the effect of one will get nullified by the other, and hence we cannot see any effect of charge in a neutral material. Right. Okay, so why this is happening? Because the charge is in balance in a neutral material. So now if you want to create a charged particle, how you can create here? You can create a charged particle by creating what? By creating charge imbalance. So how we can create this charge imbalance here? So if you take electrons out of a material, then the positive charge carriers are going to be dominant over the negative charge carriers, and hence that material is going to behave as a positively charged material. Now if you try to supply electrons, to the material, okay, that means if you dump some electrons into a material, then what will happen here? The number of electrons will become dominant over the number of protons. That means the negative charge will get dominant over the positive charge. Yes or no? And and thus it is going to behave as what? A negatively charged material. So in this manner here, by creating the charge imbalance, we can create what? We can create charged materials or charged particles. right? Okay, so once we create these charged particles here, once we create these charged particles, we can see the effect of charge. We can see the effect of charge. So what is the effect of charge here? Whenever you are having a charged particles, it is observed that they are exerting the forces on one another. They are exerting the forces on one another. So if they are of like charges, they are repelling each other. The force between them is repulsive force. If they are of unlike charges, then the force between them is attractive force. So this is the observation we have made here. Okay, okay. So now now since it is observed that the charged particles are exerting the forces on one another, now if suppose if you are having 2 point charges, then how to calculate the force between those 2 point charges? How to calculate the force between those 2 point charges? So in order to calculate the force between any 2 point charges, who will help us here? Who will help us? Coulomb will help us to determine the force between any 2 point charges. Okay, so today we will discuss about what here? We will discuss about Coulomb's law. We will discuss about Coulomb's law. I hope you all are familiar with Coulomb's law. So here I am going to explain how to write the magnitude and how to write the direction. Okay, so you can easily understand how to write magnitude, and students in generally have some confusion while representing the direction here. Okay, so that also will be clarified once we complete this lecture, right? Okay, so everything will be clarified once we complete this Coulomb's law, right? Okay, so now here what Coulomb is saying here is, whenever you are having 2 point charges, that are separated by a distance r. So if you are having 2 point charges that are separated by a distance r, then the force between those 2 point charges, is directly proportional to product of the charges. Is directly proportional to product of the charges, and is inversely proportional to what here? Square of the distance between them. Is inversely proportional to square of the distance between them. So first I will tell you how to write the magnitude of force. Okay, so then I will tell you how to write the direction. Okay, so with that it is going to be very much clear. Now see here, if you observe here, F is proportional to product of charges and inversely proportional to square of the distance between the 2 point charges. Now here, why we have put proportionality here? Why we have not put equality? Why we have put here proportionality? Because on LHS side, what are the units of force here? The units of force is nothing but what? Is nothing but newtons. Yes or no? And the units on RHS side is nothing but what? So here you are having Q1 into Q2, that is the units are nothing but Coulomb square per what? R square means meter square, right? So on LHS side the units are nothing but newtons. On RHS side you are having the units Coulomb square per meter square. That means the units on LHS side is not same as what here? RHS side. So that's why you should not put here equality. Yes or no? When you can put equality here? So if and only if the units on both sides is same. Okay, if units on both sides is same, then only you have to put equality. Now here this is force here, force. This force is depending upon what here? This force, the units of this force is newtons. Yes or no? Okay, so this parameter is depending upon what? Is depending upon Q1 Q2 by R square. This parameter is depending upon this Q1 Q2 by R square. Okay, so on RHS side we are having some different quantity, and on LHS side you are having some other different quantity, but one is depending upon the other. Understood? Okay, so how they are depending, that is given by this proportional. Okay, so F is proportional to what? Directly proportional to product of charges, and is inversely proportional to what here? Square of the distance between them, right? Okay, okay, yeah. Now now if you want to put equality here, so F is equal to, if you want to put equality, then what you have to do? You have to introduce what? Proportionality constant. So that proportionality constant, I am considering it as what here? K. So proportionality constant K into what? Into Q1 Q2 by what? Q1 Q2 by R square. Q1 Q2 by R square. Now I have put here equality. So the units on LHS side must be same as what here? The units on RHS side. And we know that the units of Q1 Q2 by R square is nothing but what? Is nothing but Coulomb square per meter square. Coulomb square per meter square. Now, what must be the units of this proportionality constant here? Such that the units on LHS side must be same as what? The units on RHS side. So, what must be the units of proportionality constant? Tell me. The units of proportionality constant must be what? Must be Newton meter square per Coulomb square. Newton meter square per Coulomb square. Yes or no? Okay. So now what will happen? Here Coulomb square, meter square will get cancelled. So the units on LHS side will become same as what here? Units on RHS side. So we have introduced a proportionality constant whose units are nothing but what? Newton meter square per Coulomb square. So therefore we can write F is equal to what? F is equal to simply K into what? K into Q1 Q2 by R square. Q1 Q2 by R square. So now what is this K? What is this K? So we have seen the units, but what is the value of this proportionality constant? What must be the value of this proportionality constant? Right? Okay. So that's what you have to see now. Now, now see here. See, let us assume this medium. Here Q1, Q2, and they are separated by some distance R. Now let us assume this medium is air medium or free space or vacuum Okay, so let us assume this medium is air medium or free space or vacuum here. Okay, so now without changing the setup here, that means I am not changing Q1 and I am not changing Q2, and also I am not changing the distance between them, yes or no? Okay, so I will take this total setup here, and keep it in some other medium. Let us assume I have keep it in glass medium here. Okay, so that means I have just changed the medium. From air medium to what? Glass medium. So whenever I change the medium, you are going to see the same force or different force here, because I have not changed Q1 and Q2 values, and I have not changed the distance between them. Just I have changed the medium from air to what? From air to glass medium. So whenever I change the medium, then it is observed that the force between the charges is also changing. Changing. Okay, now if you take another medium, let us say water medium. If you take the total setup and keep it in water medium, it is observed that the force between the charges is different when compared to glass medium and when compared to air medium. So like that, whenever you are changing the medium here, the force between the charges is also varying, changing. Yes or no? So that means the force between the charges is not only depending upon what? Is not only depending upon Q1 and Q2 and square of the distance between them. It is not only depending upon the product of the charges and the square of the distance between them. It is also depending upon what? It is also depending upon the medium in which you are calculating the force, or the medium in which you have kept these charge carriers. Yes or no? So the force between any 2 point charges is not only depending upon the product of the charges and square of the distance between them. It is also depending upon what? It is also depending upon the medium in which you are calculating the force. Right? Okay. So now here so that means in our force expression, you have to include the medium parameter also. Yes or no here? So in our force expression, you have to include the medium parameter also, because the force is not only depending upon Q1 and Q2 and R square, it is also depending upon what? Medium in which you are calculating the force. So you have to include medium parameter in this force expression. So we will include, and hence they have included the medium parameter in proportionality constant here, So this proportionality constant K is nothing but 1 by 4 pi epsilon. So the value of K is nothing but what here? 1 by 4 pi epsilon. Okay. Right. So the force between the charges, F is equal to what here? F is equal to, in place of K, just replace with 1 by 4 pi epsilon. So you will get 1 by 4 pi epsilon into what? Into Q1 Q2 by R square. So here I am talking only about magnitude of force here. Here I am talking only about magnitude of force, right? Okay. So here we have included what here? Here we have included proportionality constant. We have included medium parameter. We have included medium parameter epsilon. Okay, because the force is also depending upon the medium, right? Okay, so this epsilon here, this epsilon is equal to epsilon naught into what? Epsilon naught into epsilon r. Epsilon is equal to epsilon naught into epsilon r, where this epsilon is called as permittivity of any medium here. Epsilon is called as what? Permittivity. Permittivity of any medium. Epsilon is called as permittivity of any medium, and epsilon naught is called as permittivity of free space. Permittivity of free space. And epsilon r is called as a relative permittivity. Epsilon r is called as relative permittivity. Okay, so the units of epsilon is nothing but farad per meter. The units of epsilon naught is also farad per meter. The units of epsilon r, it has no units here. For epsilon r, it has no units. Okay. Right. Okay, so epsilon is equal to epsilon naught into epsilon r, where epsilon is called as permittivity of any medium, epsilon naught is called as permittivity of free space, and epsilon r is nothing but relative permittivity. Relative permittivity. The units of epsilon and epsilon naught is nothing but what here? Farad per meter. The units of epsilon r is no units here. It has no units. See, what is that relative permittivity? What is that relative permittivity? See here. Epsilon r, I can write epsilon r is equal to what? Is equal to epsilon by what here? Epsilon by epsilon naught. Yes or no? The units of epsilon is farad per meter. Epsilon naught is also farad per meter, and hence the units of epsilon r is, it doesn't have any units here. It doesn't have any units. Now, what do you mean by this relative permittivity? What do you mean by this relative permittivity? See, relative permittivity means you are measuring the permittivity of any medium here. The permittivity of any medium with respect to what? With respect to permittivity of what? For permittivity of free space. So you are measuring the permittivity of any medium with respect to what? With respect to permittivity of free space. Or I can say in this manner, you are measuring the permittivity of any medium in relative to what? In relative to permittivity of free space. So that means you are comparing the permittivity of any medium with respect to what? With respect to permittivity of free space here. So that is this comparison, this relative measure is given by what? This relative measure is given by relative permittivity, epsilon r. See, for example, for any medium, let us say they have given epsilon r is equal to 4. Let us say relative permittivity of some medium is equal to 4 here, is equal to 4. So what do you mean by this here? What do you mean by this? For this medium, the permittivity is 4 times that of what? 4 times that of free space. The permittivity of this medium is 4 times that of free space. Now, if I write epsilon r is equal to 2, so what do you mean by this? The permittivity of this medium is 2 times that of permittivity of free space. Yes or no? So in this manner, we are measuring the permittivity of any medium with respect to what? With respect to permittivity of free space. Yes or no? Since it is a relative measure, we call it as what here? Relative permittivity. Relative permittivity. Yes or no? And it has no units here. It has no units. So it is just a number. It is just a number. Right? Okay. Okay, yeah. So it is having another name also here. So it represents the dielectric strength of the material. So that we will discuss whenever we are discussing about capacitors. So in capacitors topic, I will discuss that one here. Okay. So here let us consider epsilon r as simply relative permittivity. Right? Okay. Okay, yeah. Okay. So now, what is the So what is the range of this epsilon r? Epsilon r is always greater than or equal to what here? Epsilon r value is always greater than or equal to 1. So the least value of epsilon r is nothing but what? Epsilon r is equal to 1. So epsilon r is equal to 1 is for what here? Is for free space. Epsilon r is equal to 1 for free space here. So for free space or vacuum or air medium So in all these cases, we will consider epsilon r value is equal to what? Epsilon r value is equal to 1. So the relative permittivity is least for what here? For free space or vacuum or air medium. So for any other medium here, for any other medium, this epsilon r value is greater than 1. This epsilon r value is greater than 1 for any other medium, right? Okay, so that means what here? What we can conclude from these things? See, we know that the force between any 2 point charges, F is equal to what? F is equal to K into Q1 Q2 by R square. So in place of K, so in place of K, I can write 1 by 4 pi epsilon. 1 by 4 pi epsilon. Epsilon is epsilon naught into epsilon r. Yes or no? So this is equal to 1 by 4 pi epsilon naught into epsilon r into Q1 Q2 by r square. So now see here. Now 1 by 4 pi epsilon naught into Q1 Q2 by r square. So this is nothing but what? This is nothing but the force in air medium or free space or not? Yes or no? So I can consider Q1 Q2 by 4 pi epsilon naught r square as F naught here, or as F air or free space, something. The force that is calculated in air medium or free space or vacuum. Okay, so divided by what? Divided by epsilon r. Yes or no? Okay, so now from here we can say that, from here what we can conclude here? See, for any other medium, epsilon r is what? Epsilon r is greater than 1. So if epsilon r is greater than 1 means the force is going to what? The force will be lesser in that medium when compared to what? When compared to air or free space or vacuum. Yes or no? So that means the force between any 2 point charges is maximum in which medium here? In free space or vacuum or air medium. So if you go to any other medium, there the force is going to be lesser when compared to what? When compared to air medium or free space. Yes or no? So the maximum force you are going to get between any 2 point charges is in which medium? It is in free space or air or vacuum. Right. So for any other medium, the force is going to be lesser than that. So that's what we can conclude here. Now one more thing I want to specify here is about this epsilon naught value here. So epsilon naught is called as permittivity of free space. Yes or no? Epsilon naught is called as permittivity of free space. So now what is the value of this epsilon naught? So you may know that its value is 8.854 into 10 to the power of minus 12 farad per meter. Okay. But here throughout our subject we are not going to use this value here. We are going to use epsilon naught value as 1 by 36 pi into 10 to the power of minus 9 farad per meter. Okay, if you simplify this one, finally you are going to get the same result here. Okay, these two are approximately equal, almost equal, these two. Okay, so instead of representing epsilon naught in this manner, 8.854 into 10 power minus 12 farad per meter, instead of representing in this manner, you can represent it as what here? 1 by 36 pi into 10 to the power of minus 9 farad per meter. So in this manner, always try to represent the permittivity of free space. So why means whenever you are writing the expression here, so here you are having 1 by 4 pi epsilon naught into 1 by epsilon r into Q1 Q2 by r square. Right. Now here in place of epsilon naught Okay, so in place of epsilon naught, if you substitute 1 by 36 pi into 10 to the power of minus 9, in place of epsilon naught, if you substitute 1 by 36 pi into 10 to the power of minus 9, what you are going to get here? Here 4 pi 1s and here 4 pi 9s. So you are going to get, if you take this to numerator, you are going to get simply 9 into 10 power 9 divided by epsilon r into q1 q2 by r square, q1 q2 by r square. So directly whenever you want to calculate the force, directly you can replace 1 by 4 pi epsilon naught with what? With 9 into 10 power 9 here. Okay, 1 by 4 pi epsilon naught you can replace with what? Simply 9 into 10 to the power of 9, 9 into 10 to the power of 9. Okay, so in this manner you can write the expression here. So if you write in this manner expression, then the then the mathematical simplification will be then mathematical calculations will be very much simplified if you represent in this manner here, right? Okay, so if you write 8.84854 something here in this expression, so it will get somewhat complicated mathematically. Yes or no? Calculation will become somewhat difficult while solving the problem. Right. So instead of that, just represent 1 by 4 pi epsilon naught with what here? 9 into 10 power 9. So always remember this value here. Always remember this value. 9 into 10 power 9 divided by epsilon r. So that is the value of 1 by 4 pi epsilon. 1 by 4 pi epsilon is 9 into 10 power 9 by epsilon r. Now in generally whenever they are asking to determine the force between any two point charges, or whenever they are asking to determine the electric field or whatever it may be, if they have not mentioned anything about relative permittivity, then assume relative permittivity as what here? As equal to 1. That means you just assume the medium as what? Free space. So by default, just assume the medium as free space if they have not mentioned anything about the medium. Yes or no? Okay. So if they have not given any epsilon r value and if they have not mentioned anything about the medium, then by default consider the medium as what here? Consider the medium as free space. Right? Okay. So I hope it is crystal clear here. So I have explained how to represent the magnitude of force between any two point charges, yes or no? So finally what we got here? F is equal to what? F is equal to 9 into 10 power 9 divided by epsilon r into q1 q2 by r square newtons. Okay, so this is the final expression we got. This is the magnitude of force here. This is the magnitude of force. So I have explained how to write the magnitude of force. Understood? Okay. So I hope it is crystal clear here. I hope it is crystal clear. Yes or no here? Is it clear here? Yes? Okay. So I hope it is crystal clear here. I hope it is crystal clear. Next. Okay. So if you are having 2 point charges q1 q2 separated by a distance r, right? Okay. So now here I have told you how to write the magnitude. Now I will explain how to write the direction. So make a note here. Make a note here always. So this note is very, very important here. This note is very, very important. Always you can write in this manner. So the direction of force between any two point charges, the direction of force between any two point charges must be always along the line joining the 2 point charges. Must be always along the line joining the 2 point charges. So this is very, very important note here. This is very, very important note, right? So the direction of force between any 2 point charges must be always what here? Must be always along the line joining the 2 point charges. Must be always along the line joining the 2 point charges. Okay, so keep this point in mind. Now here, I am taking case 1 here. Now here I am taking case 1. So in case 1, I am considering both Q1 and Q2. Both Q1 and Q2 are of same polarity. So I am considering, okay, so both Q1 and Q2 are of same polarity. So this is case 1 I am considering. Okay, so both Q1 and Q2 are of what? Are of same polarity. So in this case, how to write the direction and magnitude? See here. So now here, so here you are having Q1 and here you are having Q2. So the distance between them is, let us say, R, right? Now let us consider this point. This charge is present at a location x1, y1, z1, and this point charge is present at a location x2, y2, z2. x2, y2, z2. Okay, so now what I am considering here, both Q1 and Q2 are of what? Are of same polarity. So whenever both are of same polarity here, what is the force between them? The force between them is repulsive force or attractive force. So if both the charges are of same polarity, then the force between them is what? Is repulsive force or not? Yes or no here? So they are going to repel each other since both are of same polarity. Understood? Okay. So so now I want to determine what is the force on Q2, what is the force on Q2 due to Q1, what is the force on Q2 due to Q1. So now in which direction this Q2 is going to experience the force here? I want to determine what is the force on Q2 due to Q1. So now since this is a repulsive force, in which direction this Q2 is going to experience the force? It is going to experience the force towards Q1 or away from Q1. Q2 is going to experience the force towards Q1 or away from Q1. Tell me here. It will experience the force towards Q1 or away from Q1 because both are of same polarity. That means the force between them is repulsive force. Yes or no? So in which direction Q2 is going to experience the force? Towards Q1 or away from Q1? So it is going to experience the force away from Q1 or not? Yes or no? So this Q2 is going to experience the force away from Q1. In this direction it is going to experience the force. Yes or no? Okay. Okay. Now I want to represent the force on 2. The force on 2 due to 1 here. The force on 2. So the force on Q2 due to Q1. See, whenever I am writing the subscript, I am going to follow this convention here. What is that convention means? Here always in the subscript, first one I will write on which charge. Force on which charge. Okay. Due to which charge. Due to which charge. Next subscript will be due to which charge. So first subscript will be on which charge you are trying to calculate the force. Due to which charge you are calculating, that is due to first charge. So this second subscript will represent due to which charge. this first subscript will represent on which charge. Understood? Okay, so the force on 2 due to what? Due to 1. So this is the convention we are going to follow here. This is the convention we are going to follow. Okay, so it is not compulsory here, it is not compulsory. Some persons may follow F12 here, F12 like this. So here they will consider force on 2, here they will consider due to. Okay, so any convention you can follow here, it doesn't matter, it doesn't matter, but we have to take any one of this. So I am choosing this one. So throughout our subject we are going to follow this one here, right? Okay, okay, so the force on 2 due to 1. So this is equal to, this is equivalent to, so it is going to have what here? It is going to have both magnitude, it is going to have both magnitude as well as what? Direction. So the direction I am representing with a cap to 1, right? Okay, so remember here, remember always we are considering here magnitude. Here we are considering only magnitude. That means it must be always what here? It must be always positive. It must be always positive. Remember this here. So you are writing the only magnitude here. So irrespective of polarity here, irrespective of polarity, whenever you are calculating the force between the charges, write only magnitude here. Write only magnitude here. So this magnitude must be always what? Must be always positive. Must be always positive. See, the polarity, the effect of polarity will be taken care by what here? Will be taken care by this unit vector. The effect of polarity will be taken care by this unit vector. So I will explain here, I will explain all these things. Okay, so the effect of polarity, the effect of polarity, the effect of polarity the effect of polarity the effect of polarity is taken care by the unit vector, So if you follow this one here, then you are not going to have any confusion while determining the force here. Okay, so I will explain what do you mean by it is taken care of polarity and all these things. I will explain, don't worry, right? Okay, now okay here. Now first try to calculate the force on 2 due to 1. So 2 is going to experience, Q2 is going to experience a force in this direction, yes or no? Okay, so it will try to move away from what? Away from Q1, because both are of what? Both are of same polarity. So the force on 2, the force on 2 due to 1 will be pointing in this direction, and this is nothing but this direction, this is nothing but unit vector. I can represent this as what? Unit vector. So unit vector will point in this direction here, yes or no? Okay, okay here. Now see here, why I have set this point a cap to 1, the unit vector will take care of what? Will take care of the polarity. Why I have said this statement means, see here, if I take the same Q1 and Q2 here, if I have taken same Q1 and Q2 separated by a distance r, okay, now here in this case I said that the polarity of Q1 and Q2 both are what? Both are same. Now here in this case, if I consider Q1 as plus Q1 and here Q2 as negative charge, then what will happen here? In which direction it is going to experience the force now? Q2 is going to experience the force in this direction or not? Yes or no? Now it tries to move towards what? It tries to move towards Q1. Now the force between Q1 and Q2 is attractive force. So Q2 will try to move what? Will try to move towards what? Towards Q1. So now in this case, the force on 2 due to 1, I will represent it as what here? F2 1 bar. Now F2 1 bar is pointing in this direction. That means unit vector along this direction is going to point in this direction. Yes or no here? Unit vector is going to point in this direction. Unit vector will always take care of what? Direction. Yes or no? So the direction of force is in this direction, means unit vector is going to point in this direction. So now here the unit vector A21 cap is pointing in this direction. Whenever I change the polarity, the direction of unit vector is also changing or not? Yes or no? So that means the effect of polarity. Why the direction is changing here? Because the polarity is changed. So the effect of polarity will be taken care by what? Will be taken care by the unit vector, because whenever you change the polarity, the direction is also going to change, and we always represent the direction with unit vector, and hence the unit vector will always take care of what? Take care of direction. Take care of direction, and hence it will take care of what? Take care of polarity. Yes or no? Okay, so don't worry about the polarity and all these things here. So it will be taken care by what? It will be taken care by the unit vector, right? Okay, so I hope this point is crystal clear here. I hope this point is crystal clear, right? Okay, so now I will tell you how to write the magnitude and direction. So you know how to write the magnitude here. It is very simple. So the force on 2 due to 1 is equal to, write down magnitude of force. So that is K into proportionality constant, K into Q1 Q2 by R square, right? Always consider it as what? Positive. Irrespective of the polarity, always consider this magnitude as positive. So that's what I am saying, right? Next, you have to write the unit vector. Now, the unit vector is pointing in this direction. Yes or no? So, always the direction of unit vector will be what? Will be along the force. Yes or no? It is going to experience the force in this direction, and hence unit vector is pointing in this direction. Now, how to write the unit vector here? How to write the unit vector? I have already told that how to write the unit vector. What you have to do? You have to write the vector. You have to write the vector divided by its magnitude. Yes or no? Now, as you move from x1 comma y1 comma z1 to x2 comma y2 comma z2. See, the vector is pointing in this direction or not? That means you are moving from x1 comma y1 comma z1 to x2 comma y2 comma z2. So as you move from this point to this point, you have to represent the increment in x as x component, the increment in y will become y component, the increment in z will become z component. Yes or no? So that's how you have to represent the vector that is pointing from one point to another point. Yes or no? Okay, so first write down the vector and divided by its magnitude. So write down the vector here, write down the vector, what you are going to get. Write down the vector. So first write down the vector that is pointing from this point to this point. So as you move from this point to this point, what is the increment in x here? Increment in x is nothing but what? x2 minus x1. So x2 minus x1 will become what here? X component. So this is how you have to write the vector. Yes or no? And what is the increment in y? Increment in y is nothing but y2 minus y1, y2 minus y1 into ay cap. And what is increment in z? That is z2 minus z1 into az cap, right? Okay, so this is the vector. Now this vector divided by its magnitude is going to give you the unit vector. So divided by its magnitude. What is its magnitude here? Square root of x2 minus x1 whole square plus what? Plus y2 minus y1 whole square plus what? Plus z2 minus z1 whole square. So this is how you have to write the unit vector here, right? Okay, okay. So you have written magnitude as well as what? As well as direction, right? Okay, okay. Now similarly, if you want to determine, okay. Now similarly, here we have considered what here? Both Q1 and Q2 are of what? Same polarity. So in the same case, if you want to determine the force on what? The force on Q1 due to Q2. So how to represent here? Tell me directly now, tell me. So the force on 1 due to what? Due to 2 is equal to what? Is equal to, it is going to have magnitude as well as what? As well as direction. So what is its magnitude here? Let us say the distance from here to here is r. Okay, so now in which direction Q1 is going to experience the force here? In which direction it is going to experience the force? Towards Q2 or away from Q2? Both are of same polarity, yes or no? So that means Q1 is going to experience the force away from what? Away from Q2. So that means the force on 1 due to 2 is going to point in this direction. So the unit vector is going to point in this direction. So that is A1 2 cap. right? Now consider this point as what here? This point is nothing but x1 comma y1 comma z1, and let us consider this point. This point is nothing but x2 comma y2 comma z2. Okay. Okay, here. So now what is the magnitude of force here? The magnitude of force for F21 and F12 both must be same or not? Yes or no here? Yes or no? Only the direction is going to change. Magnitude will be same. Yes or no? So what you are going to get? You are going to get K into Q1 Q2 by R square. So magnitude will remain same. What is the direction? The direction, how to write the direction here? Direction is given by unit vector. How to write the unit vector? Write the vector and divided by its magnitude. So the vector is pointing in this direction. So that means as you move from this point to this point, you have to represent increment in x, increment in y, and increment in z. So that is going to give you the vector. Yes or no? So write down here simply x1 minus x2 ax cap plus what? Plus y1 minus y2 ay cap plus z1 minus z2 az cap. So divided by square root of what here? Square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So this is the expression we got for the force on 1 due to 2. Force on 1 due to 2. Right? Okay, so if you observe force on 2 due to 1 and force on 1 due to 2, so what is the conclusion we can make here? What is the conclusion you can make? Tell me. So the magnitude of F12 is same as what? Magnitude of F21. Yes or no? So the magnitude of F21 bar is same as what here? The magnitude of F12 bar. Yes or no? Next, this A12 cap, this is nothing but what? A21 cap, and this is nothing but what? This is nothing but A12 cap. Now if you observe, A21 cap is pointing in this direction, A12 cap is pointing in this direction. Both are what? Both are exactly opposite to one another. Therefore I can say A21 cap is opposite to what? Opposite to A12 cap. So finally you can write, therefore F21 is equal to what? Minus of F12. Yes or no? So this is the conclusion we can make here. This is the conclusion we can make. Yes or no? Okay. Is it clear here? Is it clear how to write the direction? Always what you have to do? Write the magnitude and then separately write the direction here. So the direction will take care of what? The direction will take care of polarity. Direction will take care of polarity. So whenever you are writing the magnitude, always write it as positive irrespective of the polarity. Understood? The effect of polarity will be taken care by the unit vector. Okay, so these things you have to keep in mind. How to write the unit vector, that is direction, and how to write the magnitude. So here we have considered case 1, that is both Q1 and Q2 are of same polarity. Now if you consider case 2 here, so case 2, what is case 2 here? If Q1 and Q2 are of opposite polarity, So if both are of opposite polarity, then how to determine the force? So here let us say Q1. See, magnitude wise there will be no change here. Magnitude will be same. Yes or no? Okay. Magnitude must be always positive. Yes or no? So now what is the force on 2? Due to 1 is equal to what? Now here Q1 and Q2 are of what? Are of opposite polarity. That means the force between them is attractive force. That means in this case the force on 2 due to 1. In which direction Q2 is going to experience force here? So it is going to experience a force towards what? Towards Q1, because now it is experiencing an attractive force. So the force on 2 due to 1, now it is going to point in this direction. Yes or no? So that means you have to represent the unit vector in this direction. So now in this case, A21 cap is going to point in this direction here, or you can write here, instead of writing here, you can write. So Q2 na, so Q2 is going to experience the force in this direction. So you can write A21 cap. A21 cap is going to point in this direction, right? Okay. Now F21 bar is equal to what here? Is equal to K into Q1 Q2 by R square. So this is the magnitude. Now what is the direction here? Let us consider this point is x1 comma y1 comma z1, and this point is x2 comma y2 comma z2. Okay, so what you are going to get? So as you move from this point to this point, write increment in x. So that is x1 minus x2 ax cap plus y1 minus y2 ay cap plus z1 minus z2 az cap, divided by what? Divided by square root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. See, in the previous case, in case 1 and in case 2, the magnitude will remain what? Is remaining same. Even though the polarity of charge carriers has changed, the magnitude will remain same. Yes or no? So the effect of polarity will be taken care by what here? Taken care by this unit vector. Previously we got A21 cap is pointing in this direction. Now A21 cap is pointing in this direction. Yes or no? Why the direction of unit vector is changing? Because the polarity has changed now. Right? Okay. So that's what I have said. Always the effect of polarity will be taken care by unit vector. So, and hence whenever you are writing the magnitude, don't include the effect of polarity. Always write it as what? Always this must be positive. Always this must be positive. Remember that. Okay. Okay. So in the same manner, you can determine the force on 1 due to 2. So if you want to determine force on 1 due to 2, in which direction Q1 is going to experience the force? It is going to experience the force towards Q2. Yes or no? So in the same manner, you can write the expression here. So magnitude will remain same, but the direction now, in this case, it is going to point in this direction. Yes or no? Now unit vector is going to point in this direction. And I have told how to write the unit vector also. Understood? So similarly, you can determine the force on 1 due to 2. So you try to write the expression for this one here in the same manner, right? Okay. So this is how you have to write the magnitude and direction whenever you are calculating the force between any 2 point charges, right? Okay. So Coulomb has told how to determine the force between any 2 point charges. So what we have to do or how to calculate the force if you are having more than 2 point charges here. If you are having more than 2 point charges, then how to determine the force? Okay, so whenever you are having more than 2 point charges, then you have to apply what here? Then you have to apply superposition principle. Right? Okay. So what do you mean by superposition principle? So it is very simple here. See here, if you are having Q1 charge here, and here Q2 charge, and here you are having Q3 charge. Let us assume here you are having Q4 charge. Let us assume Q1, Q2, Q3, Q4 all are of same polarity. Let us assume all these 4 charges are of same polarity. Now if you want to determine the force experienced by Q4, due to Q1, Q2 and Q3. So then how you can determine here? What you have to do? You have to apply what? You have to apply superposition principle. So what do you mean by superposition principle? Now take any 2 point charges at a time and calculate the force. Okay, so take these 2 point charges here and determine the force on 4 due to 1. Since both are of same polarity, we have assumed all are of same polarity. Okay, so since these 2 are of same polarity, it is going to experience the force in this direction, that is away from Q1. So the force on 4 due to 1. We know how to calculate the force between any 2 point charges. Yes or no? Okay. In the same manner, now take these 2 point charges. Now consider these 2 point charges. Now determine the force between these 2 point charges. Yes or no? So this is the force on 2 due to 4. The force on 4 due to 2. Force on 4 due to 2. So it is going to point in this direction because both are of same polarity. Now calculate this force on 4 due to 2. Next, consider these 2 point charges. Now determine the force on 4. Now determine the force on 4. Okay, force on 4 due to what? Due to 3. So take any 2 point charges at a time and determine the force Now, if you want the net force acting on Q4, then what you have to do? You have to add up all these forces. So take, if you are having more than 2 point charges, take 2 point charges at a time and then calculate the force between them. Next, take another 2 point charges and calculate the force between them. Next, take another 2 point charges and calculate the force between them. Now add up all these forces here. So that is going to give you the resultant force that is acting on Q4 due to all the other 3 charges. So this principle is called as what here? Superposition principle. Right. So here the net force on 4 due to, this is how I am going to represent here. F4 net means the net force experienced by 4 due to all the other 3 charges. So this is equivalent to force on 4 due to 1 plus the force on 4 due to 2 plus force on 4 due to 3. Okay, so you have to add up all these forces in order to get the net force or resultant force on Q4. So this principle is called as what here? This principle is called as superposition principle. This principle is called as superposition principle. Right. Okay. So is this clear here? Is this clear? Yes. Yes or no here? So I hope it is crystal clear here. This is superposition principle, right? Okay. So now based on this superposition principle, okay, and we have also seen how to write the force between any 2 point charges. So based on whatever we have studied up till now, based on this we try to solve some problems here. Okay. 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 So we try to solve some problems based on this, right? First I will take one simple problem here. So now let us consider you are having 1 microcoulomb of charge. Let us consider you are having 1 microcoulomb of charge here, and here you are having another 1 microcoulomb of charge, and here you are having minus 1 millicoulomb of charge. So here you are having minus 1 millicoulomb of charge, and here you are having 1 microcoulomb of charge, and here you are having 1 microcoulomb of charge. So let us say this 1 microcoulomb of charge is placed at 0, 0, and this 1 microcoulomb of charge is placed at 0, 1, and let us assume this minus 1 microcoulomb of charge is placed at 1, 1, and let us consider this axis as x-axis and this axis as y-axis. Okay. Okay. So here you are having 3 point charges. Here 2 point charges are placed along y-axis. So that is 1 microcoulomb is placed at 0, 1, and another 1 microcoulomb is placed at 0, 0, and minus 1 millicoulomb is placed at what? Is placed at 1, 1. Now they are asking to determine. Determine the net force. Determine the net force on minus 1 millicoulomb. determine the net force on minus 1 millicoulomb of charge. Okay, so that means here you are having 1 microcoulomb here, 1 microcoulomb here, here minus 1 millicoulomb. They are asking to determine what? To determine the net force on minus 1 millicoulomb due to what? Due to these two 1 microcoulomb of charges. Yes or no? Now let us name this one here. Let us name this one as Q1. Let us name this one as Q1, and let us name this one as what? This one as Q2. Right, and minus 1 millicoulomb, let us name this as Q3. Let us name this as Q3. Right. Okay. Now you have to determine the net force on Q3 due to Q1 and Q2. So that means you have to determine the net force on 3. Net force on 3 due to what? Due to Q1 and Q2. Okay. That means you have to determine force on 3 due to 1. So you have to determine force on 3 due to 1 plus what? You have to determine force on 3 due to 2. So that is force on 3 due to 2. So if you add up these two, you are going to get what? You are going to get the net force on 3. Yes or no? Okay. So how to determine this one here? See here. Now first we try to determine F3 1 bar here. F3 1 bar. Now first write down the magnitude here. Write down the magnitude. So okay, so you have to write what I have told here. First write down the magnitude and then write down the direction. Yes or no? Okay. Okay. So first write down the magnitude here. What is the magnitude of force between Q1 and Q3? Is nothing but what? Q1 into Q3 divided by what? Divided by 4 pi epsilon r square. So now since they have not mentioned anything about the medium, consider epsilon r is equal to 1. Okay, so here you are having 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught, you can represent it as what here? Simply 9 into 10 power 9. Yes or no? So here I am representing 9 into 10 power 9. So this is 1 by 4 pi epsilon naught value into Q1 Q3 by r square. So let us say the distance between these two. What is the distance between these two here? Here you are having 0, 0 and here you are having 1, 1. What is the distance between these 2 points? Is nothing but what? Square root of 1 square plus 1 square. Yes or no here? Yes or no? So that means the distance between these two charges is nothing but what? Is nothing but root 2. The distance between these two charges is root 2. Right? Okay. Next. So here we have written 1 by 4 pi epsilon naught value, that is 9 into 10 power 9 into what? Into Q1 Q3. So here 1 microcoulomb into what? Into 1 millicoulomb. What I have told here, whenever you are writing the magnitude, don't consider the polarity. Always write it as what? Positive. Always write it as positive. So that means 1 microcoulomb into 1 millicoulomb. So that is 10 power minus 9. 10 power minus 9. So this is Q1 into Q3. So divided by what? Divided by square of the distance between these two. So what is the square of the distance between these two? That is root 2 whole square. Right? Root 2 whole square. So this is the magnitude here. This is the magnitude of F31. Next you have to write the direction. Now if you observe 1 microcoulomb and minus 1 millicoulomb, both are of what? Both are of opposite charges. Both are of opposite charges. That means the force between them is attractive force. The force between them is attractive force. That means in which direction this this Q3 is going to experience the force here due to Q1? In which direction it is going to experience the force? It is going to experience the force towards what? Towards Q1, because the force between them is attractive force. So Q3 is going to experience the force towards what? Towards Q1. So that is, this is force on 3 due to 1. So this force is going to point in this direction. Yes or no? That means you have to write the direction. That means you have to write the unit vector along this direction. Yeah, you have to write the unit vector along this direction. Now, how to write the unit vector here? So write down the vector along this direction divided by its magnitude. So now, how to write the vector? As you move from 1, 1 to 0, 0. As you move from 1, 1 to 0, 0, because the vector is pointing in this direction. So you have to move from 1, 1 to 0, 0. You have to write the increment in x as x component, increment in y as y component, increment in z as z component. So what you are going to get? Increment in x is nothing but 0 minus 1, that is minus ax cap. And increment in y is nothing but 0 minus 1, that is minus ay cap, divided by what? Divided by, this is the vector divided by its magnitude. Its magnitude is what? Root 1 square plus 1 square, that is root 2. Yes or no? So this is the magnitude. This is the magnitude of F31 and this is the unit vector. This is the unit vector. Right? Okay. So you have represented F31. Now similarly you can represent F32 bar, that is the force on 3. The force on 3 due to 2. Okay. So now now see here. So now you have to determine the force on 3 due to 2 here. Now if you observe Q2 and Q3 are of what? Are of opposite polarity. Are of opposite polarity. So in which direction Q3 is going to experience the force? We are determining the force on Q3. Yes or no? So in which direction Q3 is going to experience the force? So Q3 is going to experience the force towards what? Towards Q2. Yes or no? So this is force on 3 due to what? Due to 2. So Q3 is going to experience the force towards Q2. Right? Okay. Okay, yeah. So now write down the magnitude of F32. So what is the magnitude here? What is the magnitude? Q2, Q3 divided by what? Divided by 4 pi epsilon naught into r square. Yes or no? So 1 by 4 pi epsilon naught value is 9 into 10 power 9. 9 into 10 power 9 into Q2 into Q3, that is 1 micro into 1 milli, so that is into 10 to the power of minus 9. So always consider only positive magnitude, right? So divided by square of the distance between these two. What is the distance between these two? Distance between 0, 1 and 1, 1 is how much here? Is nothing but 1. Yes or no? So the distance between these two charges, is nothing but what? Is nothing but 1. Right? Okay. So here you will get r square, that is 1 whole square. So this is the magnitude here. This is the magnitude. Now you have to write the direction. See here. See. So you have to write the unit vector along this direction here. Along this direction. See, if you observe, this direction is along which direction here? It is along negative x direction or not? Yes or no here? See, this direction is along which direction? It is along negative x direction. Yes or no? So along negative x direction, what is the unit vector? It's nothing but minus ax cap or not? Yes or no? So you can directly write the direction here, minus ax cap. Or if you want to follow the procedure, you can follow. You are going to get the same thing here. Yes or no? So write the vector that is pointing from here to here and divided by its magnitude. You are going to get the same thing, minus ax cap. But there is no need to calculate and all these things here, because this vector is pointing in negative x direction. We know that along negative x direction, the unit vector is nothing but minus ax cap. Right? So in this manner you can directly write. So this represents what here? This represents the magnitude of what? Magnitude of F32 bar, and this is nothing but what? This is nothing but unit vector A32 cap. Okay, now you can simplify this one here. Now here 10 power minus 9 will get cancelled. Yes or no? Here also 10 power minus 9 will get cancelled. Now add up the x components and y components. So what you are going to get? Tell me what you are going to get. Here you will get 9. Here root 2 whole square means 2. Here root 2. So you will get 9 by 2 root 2. 9 by 2 root 2 minus ax cap. Plus 9 by 2 root 2 minus ay cap. Yes or no? Next here what you are having? Simply 9. Yes or no? Plus 9 into minus ax cap. Now add up the x components. What you are going to get? 9 by 2 root 2 plus 9 into minus ax cap plus 9 by 2 root 2 into minus ay cap. So this is the net force on 3. So in this manner you can determine the force between in this manner you can apply the superposition principle and determine the force on one charge due to all the other three charges. Yes or no? Okay. So you can simplify this one here, you can simplify this one, and you can write the exact values, right? Okay, okay. Or you can write the same thing as minus of 9 by 2 root 2 plus 9 into ax cap minus 9 by 2 root 2 into ay cap. Both are correct only here, both are correct only. Okay, okay. So in any manner you can write the answer. So this is how you have to determine the net force on one charge due to other charges, right? Okay. So I hope it is clear here, I hope it is crystal clear, right? Okay. Okay. So is this clear here, how to calculate, right? See, I will give one problem here, so you try it at home here. Okay. So simple problem here, simple problem I will give, just based on this superposition principle only, just for practice, I will give you one example. Try to solve this one here, So example, let us take Q1 is equal to 2 microcoulomb located at 3, 2, 1. Q2 is equal to minus 1 microcoulomb located at minus 1, 1. Next Q3 is equal to 5 millicoulomb located at 0, 5, 1. Located at 0, 5, you can take 3. Okay, 0, 5, 3. Okay, 0, 5, 3. Next, determine net force. On Q3 due to Q1 and Q2. So determine the net force on Q3 due to Q1 and Q2. Okay, so it is very simple problem here, just for practice I have given this problem. So I hope you can do this one easily. See, whenever they give, I will give one simple clear, whenever they have given the problem like this. So they have said that Q1 is equal to 2 microcoulomb, it is located at 3, 2, 1, and Q2 is equal to minus 1 microcoulomb located at minus 1, 1, and Q3 is equal to 5 millicoulomb located at 0, 5, 3. Understood? See, whenever they have asked the problem like this, don't try to draw the coordinate axis and try to locate these points here. Okay, so your time will get wasted if you try to draw the coordinate axis and try to locate these points. It is not at all needed. Understood? Okay, so what you will do here is just consider somewhere here. Let us consider Q1. It is located at 3, 2, 1, right, like this, and here you can write Q2. So Q2 is located at minus 1, 1. Here write down Q3 is located at 0, 5, 3. Yes, okay, so Q3 is located at 0, 5, 3. So just represent Q3 somewhere here. Okay, so this is at 0, 5, 3. Right, now you have to determine the force on Q3 due to Q1 and Q2. That's it. So just follow the procedure here. Now here if you observe, Q1 is positive and Q3 is also positive. So Q1 is 1, 2 microcoulomb and Q3 is what? Q3 is 5 millicoulomb and Q2 is 1 minus 1 microcoulomb. So if you observe Q1 and Q2, both are of same polarity. So the force on Q3 due to Q1 is going to point in this direction. Force on 3 due to 1. Okay, so determine this one. So you know how to write the magnitude and you know how to write the unit vector, that is direction. Yes or no? Okay. Okay, whenever you are writing the unit vector, what you have to do? You have to write the vector that is pointing from this point to this point. Yes or no? Divided by its magnitude. right? Okay, next you have to determine the force on Q3, due to what? Due to Q2. Now here Q2 is minus 1 microcoulomb, Q3 is 5 millicoulomb. So both are of what? Both are of opposite polarity, yes or no? So that means it is going to have what? Attractive force. That means Q3 is going to experience the force towards what? Towards Q2. So the force on 3 due to 2 is going to point in this direction. So first represent this one. Now it is going to be very simple. So the net force on 3 is equal to what? Is equal to the force on 3 due to 1 plus the force on 3 due to 2. Now write down the magnitude and then write down the unit vector. You know how to write down the magnitude and you know how to write down the unit vector. So just substitute those values and add up the x components in both the forces and add up the y components and add up the z components. Then you are going to get the total net force. Understood? Okay. So in this manner you have to solve the problem here. Okay. So can you do this one here? Can you do this one? Yes or no? Tell me here. Can you do this one here? It is very simple problem here. So I have given it as homework here. I am giving it as simple homework problem. Okay. So I hope you can do this one. I hope you can do this one. Right? Yes or no? Okay. So okay here. So with this I am winding up the session here for today. So tomorrow we try to solve some more interesting problems here. So tomorrow we will try to solve some more interesting problems based on this Coulomb's law. So once we complete that, then we will go for electric field and then Gauss law here and then Gauss law. Okay. So for today's session I am winding up the session with this, right? Okay. So I hope everybody has understood these things clearly. So it is not at all tough here, it is going to be very simple. So I hope everybody has understood clearly. Okay. So I hope the class is crystal clear here. So everything I hope you have understood, right? Okay. So with this I am winding up the session for today's class. So tomorrow we will do some more interesting problems based on Coulomb's law. So once we complete that, then we will start electric field and then we will start Gauss law here. Okay. So okay here. So we will meet tomorrow exactly at same time here, exactly at 4 p.m. So daily EMT class will be conducted exactly at 4 p.m. on every day exactly at 4 p.m. in our Gate Academy global channel. Okay. So try to attend all the sessions here so that you can easily understand the subject here. Okay. So everything I am explaining in a crystal clear manner. If you want, you can go through my previous lectures also. Understood? Okay. So there I have discussed all the basics here, all the basic mathematical part that is needed to understand the subject. All those things about gradient, divergence, curl, coordinate system, all these things I have discussed in the previous sessions. Okay. If you want, you can go through those sessions also, right? Okay. Okay. So with this I am winding up the session here. So tomorrow we will meet exactly at the same time. So until then, take care. Bye bye.